Hi, this is Kate, and we're learning about direct and inverse variation. This is a little puzzle for you to try called Complete My Rectangle. You're given the lengths and widths of several different rectangles. These follow a pattern. See if you can find the pattern and figure out the missing width. Here's a hint. The area of all of these rectangles is 36. You can change your answer or select the same answer. The missing width is 3 because 12 times 3 is 36. The lengths and widths of rectangles with the same area fit a pattern called inverse variation. Another way to say this is that the length and width vary inversely. Quantities that vary inversely have a constant product. Remember, a product is what you get when you multiply things. In this case, when you multiply the length and width, you get a constant value of 36. 36 in this instance is called the constant of variation. Length times width is always 36. One more thing to notice about quantities that vary inversely are as one increases, the other one decreases. For rectangles with the same area, if the length is longer, the width has to be shorter. So what would be the length of this rectangle if the width was 1/2 or 0.5? The length would have to be 72. The unknown length times 0.5 has to equal 36. So you could think half of what is 36? Half of 72 is 36. Or you could solve this equation by dividing both sides by 0.5. So I'd like you to try a different problem. This is not about the same rectangle. This is about two new values, x and y, which vary inversely. X is 30 when y is 6. So what would be the x value when y is 18? The corresponding x value would be 10. We're told that 30 and 6 go together and that x and y vary inversely. Since 30 times 6 is 180, that means that x times y will have to always equal 180. This is inverse variation. Well, we want to find x when y is 18. So what times 18 is 180? 10. This is a different type of relationship. A runner is training for a marathon and logs his distance that he runs and the time it takes him to run for several training runs. Look at the table carefully and see if you can figure out how many hours it'll take him to run 18 miles. It would take him 3 hours. You could have reasoned this out in many different ways, but I want to point out some of the features of this distance and time relationship. When traveling at the same speed, distance and time have a relationship called direct variation. We can also say they vary directly. Another way to say vary directly is that the two quantities are in a direct proportion. And one of the ways you could have figured out the 3 hours is to set up a proportion for two different runs. 12/18 is the same as 2/3. Another way you could have figured it out is to notice that the distance divided by the time was constant for each run. This runner always tends to run at 6 miles per hour. His distance divided by time, which is his rate, always comes out to be 6. In this case, 6 is called the constant of variation. One more thing to notice about a directly variable relationship is that one quantity increases, the other one also increases. When traveling at a constant speed, if you go a further distance, it's going to take you more time. Let's see if you can apply this to a new problem. A car salesman's commission varies directly with the price of a car he sells. He earns $2,000 for a car that costs $16,000. Predict his commission for a car that cost $40,000. His commission would be $5,000. The two quantities that go together are 2,000 and 16,000, and the problem tells us these two quantities vary directly. Therefore, when we divide them, we're going to always get the same thing. We're going to get a constant value. Since 16,000 divided by 2,000 is 8, that means anytime we divide the cost of the car by the commission, we'll get 8. We know the cost of the new car was $40,000. So to answer the question, we think 40,000 divided by what comes out to be 8. And that would have to be 5,000. To summarize, another way to say inverse variation is to say two quantities vary inversely. We can also say they're inversely proportional. When quantities vary inversely, they have a constant product. When you multiply them, you always get the same thing. That product is called the constant of variation. When two quantities vary inversely, if one increases, the other one decreases. Another way to say direct variation is to say two quantities vary directly. We can also call them directly proportional. Two quantities that vary directly have a constant quotient. When you divide them, you always get the same thing. This value is called the constant of variation. In direct variation, if one value increases, the other one also increases. Look at the two tables carefully. Which table represents inverse variation with the associated constant of variation? Table B represents inverse variation. When you multiply the x and y, it always comes out to be the same thing. The constant of variation is 20. In Table A, you always get the same thing when you divide the two numbers. Y divided by x in each case is 1/5. Table A would represent direct variation. This is Kate, and you've been learning about direct and inverse variation.